like this or an idea like that. So whenever there is any form of slant, we're dealing with gradient. Now, let's view what gradient really has to do with. Let's consider having this hill, and here is a man at point A on the hill. This is him at point B, and here he is at point C, and here he is at point D. Now, he's at different points on the hill. Mark you, he's going that this is his journey. He wants to reach over here. So we're looking at an horizontal distance that he has to cover. And at the same time, while he's covering that, we do realize that there is a vertical distance that is changing along with the horizontal distance. So let's look at him at point A. At point A, he would have been this high in the here, and he would have been covering this distance. By the time he reaches B, he's now this tall in the here, that high, and he would have covered a little bit more distance horizontally. By the time he is at C, he would have been this high in the here, and he would have covered a little bit more distance to the right. Finally, at D, he is this high in the here, and he had covered more distance going that way. So you could see that going up the slope, going up this slope, right? A lot of things change. Two things basically change going up the slope. So here is the slope. He's going up the slope. Two things change. One, his vertical distance changed. Two, his horizontal distance changed. Now, what gradient really deals with? Gradient deals with the vertical change over the horizontal change. There is a relationship. Some people may call it rise over run. When we go on the Cartesian plane, the gradient, however, is looked at the change in the y divided by the change in the x. Mark you, the y-axis is the vertical axis, and the x-axis is the horizontal axis. And so change in y over change in x does give the gradient. Now, let's look at some numbers. Let us say we have a point A, which a coordinate 3, 5, and we have a point B with a coordinate 1, 7. If we intend to find the gradient of this line segment connecting the point A to B, first thing we want to do is to label our coordinates x1, y1, x2, y2. Now, the gradient is simply y2 minus y1 over x2 minus x1. This is really equal to 7 minus 5 over 1 minus 3. Finally, 7 minus 5 would have given us 2. 1 minus 3 would give us negative 2. So finally, the gradient is negative 1. All right, so finally, the gradient is negative 1, as you could see here. So basically, that's gradient. Let's look at another point. We have a point, let's say we have a point D with coordinate 0, negative 1, and we have a point E with coordinate 1, 6. If we intend to find the gradient of this line segment, we need to label the points x1, y1, x2, y2. Gradient can be calculated easily by using the formula y2 minus y1 over x2 minus x1. Here, 6 represents y2 minus negative 1, which represents y1. 1 represents x2 here, minus 0. Finally, 6 minus minus, these two negatives will give us a plus. So we're looking at 7 over 1. You could say finally the gradient is 7. All right, thank you for watching this. See you next time.